So once again, you're welcome back to our online lesson, Math Made Easy with connection with e-learning Ghana. We are presenting to you an interesting lesson for elective math today. So in our previous lesson, we started with quadratic functions, and then we found out that when it comes to quadratic functions, they are simply functions for which the highest exponent of the variable under discussion has a degree of 2. So quadratic function is actually a type of polynomial function for which the highest degree of the variable under discussion must be 2. And then we did a whole lot. We also found out that the nature of graph for any quadratic function is parabola. And then we went further. Now today we are looking at how to determine the vertices of a quadratic function. That's what we'll be sticking to today. How to determine the vertices. Now another word you can use for the vertices is simply the turning point. How to determine the turning point of a quadratic function. That's what we'll be doing today. But before I move on to today's topic, then I have to consider the question I left with you. I said this is the question. What type of curve does these graphs produce? Is it going to be a maximum curve or a minimum curve? That's what I wanted you to actually tell me. But it's unfortunate I didn't get any feedback from here. So I'll just take a couple of the questions and then we move on. Now, so question number 1. We have the function as f of x equal to x squared plus 4x plus 2. Now, what type of graph are we going to determine from here? Yes, anyone with an answer? Is it going to be minimum or maximum?
Sir, please, minimum.
It's going to give us a minimum curve. Why do you think this is going to give us a minimum curve?
Because the coefficient of x squared is positive.
Thank you. Thank you. That is wonderful. So automatically, all the questions over here for which the coefficient of x squared is a positive number is automatically giving us what we call a minimum curve. It's giving us a minimum curve. So number 1 is minimum. Number 1 is minimum. Number 6 is minimum. Number 8 is minimum. Number 5 is minimum. So apart from all those numbers, the rest are going to be maximum curves. And as I told you, when we talk about minimum curve, then it means that the graph is holding water. If it is a maximum curve, the graph is pouring water. So a parabola holding water, a parabola pouring water, or a calabash holding water and a calabash pouring water. So that's the whole idea here. I hope everyone understands it. Then I move on to our activity for today. Are we all clear? So that I move on.
Yes, sir.
Wonderful.
Yes, sir.
So since this is clear, then moving on to today's topic, and as I told you, we are trying to determine the vertices. So you see, this question as we have here, it's another question for you. You'll be doing this at the end of the day. Find the vertices of a parabola formed by the following functions. You have to find the vertices. That's what we are going to do today. So automatically, this same question is coming back to you, but this time you are answering finding the vertices. So I'll take 1 or 2 examples and then I'll show you the various ways by which you can determine the vertices, and then we move on from there. So now let me switch to our tool. As I said, the vertices is the same as the turning point. It's the same as the turning point. So let me switch to the tool, do some graphical explanation. Then from there, I'll come and show you the calculation means by which you can use to determine the vertices. And as you know, our tool is the GeoGebra. So I'm switching to the tool. As I said, we are looking at how to determine the vertices, but I want us to use the graphical means to understand it. Then from there, I'll come and show you the calculation means. So let me program this function. We had a question early on. The function was f of x equal to x squared. So let me just key this x squared, then plus 4x plus 4x, and then plus 2 plus 2. Okay, so enter. So that is the graph for f of x equal to x squared plus 4x plus 2. Automatically, this graph is a minimum graph as we did early on. Now we want the vertices. So ideally, the vertices is the turning point. So this is where we have the turning point. Now let me click on this dot. When I click on this dot, you see it's written extremum. It's the same as a turning point. Now what values are being shown at the turning point, please? Can you tell me? Yes, what values are being shown?
-2 and -2.
Good. This -2 and -2 is coordinate of what we call the line of symmetry and then the corresponding value for y, or the y value. So the line of symmetry, as I said last week, was or is a vertical line that is drawn to partition the graph drawn vertically into two equal halves. So in case we want to draw a vertical line to partition this graph drawn into two equal halves, it will pass through -2 on the x-axis. To pass through -2 on the x-axis. That's why we have the first coordinate, which is the x-coordinate, as -2. And then when this vertical line or this line of symmetry intersects with the graph drawn, then you trace it towards the y-axis to read the corresponding value for y. My people, are you with me?
Yes, please.
So it means
Yes.
the line of symmetry and then the corresponding value for y together gives you the turning point. The line of symmetry, the corresponding value for y gives you the turning point or the vertices. So in this case, per this graph, the vertices is -2, 2. So graphically, I've explained how to get the vertices or the turning point of a given quadratic function. Let us go to another one. So I'm bringing in a new graph. This time around, we are taking a graph which is maximum. So let me actually bring on board -3x squared, -3x squared minus x, and then plus 1 plus 1 plus 1. Okay, so enter. Now we have this graph there. Let me de-highlight the first graph so that we can concentrate on this first, the second graph here. Now, considering the second graph, let us locate the vertices. This is where the vertices is, and that's where the extremum is showing. And if you look at it carefully, the x value or the line of symmetry is at -0.16666. That's a recurring value. And then the corresponding value for y is +1.08333, which the 3 is recurring. So that is where you have your extremum. And in this case, what it means is that this is a maximum graph for which you have the turning point as where I actually showed you. My people, are you also clear with that also? Are you clear with that?
Yes, sir.
So graphically, this is how we determine the vertices. That is how you determine the vertices. But right now, we are going to find out how to determine the vertices using the calculation means. I'm going to show you all different options that you have. I'm going to show all that to you so that you determine or you use which one that you are comfortable with. So let me switch my screen back to our board. The vertices, we are looking at the vertices. The vertices of a quadratic function. So when we talk about the vertices is made up of two coordinates, x and then y coordinates. Now the x coordinate is automatically what we call the line of symmetry. The line of symmetry. That's the x coordinate, and then the y coordinate is actually corresponding value for y. Corresponding value for y when the line of symmetry intersects with the graph. When line of symmetry intersects with curve. Okay, so we have ways and means we can determine the vertices. We have different ways and means that we can use to determine the vertices. Now, let me show you one method. So we are looking at first method. So considering first method, if a function is given to us like this, watch this carefully. I'm going to do some calculations here. So watch it carefully. If we have our function f of x as a quadratic function known as ax squared plus bx plus c. Now, please follow this procedure carefully. A formula is given as x equal to minus b over 2a. This formula here is used to determine what we call the line of symmetry. This formula here is used to determine the line of symmetry. So when you get your line of symmetry, then you can substitute the answer for the line of symmetry into the function to get a corresponding value for y. Then the two values together will give you the vertices. Now, how was this formula deduced? How was this formula deduced? That's what I'm going to show you right now. So I don't just want you to chew this into your mind, but you should understand how this idea came on board. So this is how it was generated, how to determine the line of symmetry, how we had this. From f of x equal to ax squared plus bx plus c, now we will use an idea of what we call completing of squares. So we'll use an idea of what we call completing of squares method. So having f of x equal to ax squared plus bx plus c, what you must do is first you must make sure that the coefficient of x squared is 1. It's 1, but whatever we are having here is a variable a. So we just have to factorize out the coefficient of x squared. So a out into brackets x squared plus b over a x plus c over a. Please, do you all understand the factorization that I've made here?
Yes, sir.
Now, per whatever I've written here, when you expand the a through the brackets, you end up getting what is up here. Okay, so that's the first step. Now, after that, a is maintained, and this time around, we are going to make the expressions in the brackets a perfect square. So to make it a perfect square, this is a procedure we go through to make the expression in the bracket a perfect square. X squared plus b over a all x then plus c over a. Now this is what we are going to do. We are going to pick the coefficient of x, half it, square it, and add and subtract. It's a combined operation, so listen to it carefully. The next step is select the coefficient of x. First, half it. The coefficient of x is b over a. We are going to half it. When I mean half it, it means divide it by 2. When you divide b over a by 2, you end up getting an answer of b over 2a. Do you understand that? When you divide
Yes,
b
please.
over a by 2, you end up getting b over 2a. If you don't understand why it became so, this is why it is so. B over a, then the division sign will be turned into multiplication sign. Then the 2 will reciprocate it and have it as 1 over 2. So you end up getting b times 1, which is b, 2 times a, which is 2a. So when you divide b over a by 2, you end up getting b over 2a. Then the answer we've obtained, we square it. So we square it, add and subtract it. So we are going to have plus b over 2a all squared. We add it to the variable x and then subtract it from the c over a. So we'll have it as minus b over 2a all squared. Please, have you understand the process that I went through here? This is giving us the idea of how to make the function in the brackets a perfect square. And that's the process I've gone through. Please, do you all understand that?
Yes, please.
Okay. We are moving forward. We are moving forward. So since we've gotten that fact right, then what we must do is that we maintain our a, and then automatically the inner function has become what we call a perfect square. So we write the factors of this perfect square. We can consider the first 3 terms, and the factor is going to give us, pick one of the x's here, pick one of the factor there, and that will give you x plus b over 2a. Then you square both. So this automatically becomes a perfect square, and there's a factor for that. Then plus c over a minus b over 2a all squared. We can simplify it and obtain c over a minus b squared over 4a squared. I've just expanded the square to the b and then expanded the square to the 2a. So this is what I'm getting here. Now going further, we are almost through. Going further, this is what we are going to obtain. Going further, this is what we are going to obtain. We can merge these two like terms. They are numbers, so we can merge them. So when we merge them, we still have x plus b over 2a all squared. Then plus, now let us do this side work and let me write the final answer there. So having c over a minus b squared over 4a squared, LCM is going to be 4a squared. A will go into 4a squared 4a times, multiplying c will end up getting 4ac. Are you clear with the first one? Are we clear?
Yes, sir.
Then minus 4a squared will go into itself 1, multiplying b will get minus b squared. So this is what we've obtained at the end of it all. This is what we've obtained. That when you add up c over a minus b squared over 4a squared, you end up getting 4ac minus b squared all over 4a squared. Please, are we all clear with that also?
Yes, please.
All right. We are almost through. We are almost through. So then we can further expand. So our f of x now will be equal to, now we can expand the a through the bracket. We can expand the a through the bracket. When we expand the a through the bracket, we end up getting a into bracket x minus b over 2a all squared. When you multiply this a through, this is what we are going to obtain here. Then plus a multiplying 4ac minus b squared all over 4a squared, which we can further write it as, which we can obtain it finally as a into brackets x minus b over 2a all squared. And this a can cancel one of the a's at the denominator here. So you end up getting plus 4ac minus b squared over 4a. This expression here is very key to what I'm going to talk about today concerning the vertices. Take note of this expression here carefully. So now I told you about the line of symmetry is given by the expression minus b over 2a, and this is where it's coming from. My people, are you with me?
Sir,
This is where it's coming from.
sir,
Yes, please.
please, the first term. Why didn't the A cancel the other A?
You mean this side?
No.
This
Yes,
one?
the first
Are you
term.
talking of this? The first?
Yes. Yes, please. This one, yes.
This line?
F of x equals A into brackets x minus b over 2a squared.
Okay. Now, this a outside here cannot cancel the 2a here for the fact that before it can cancel, then I need to expand the x minus b over 2a all square before the a can be expanded through. Then any form of cancellation can be done. But if you look at this expression that I have here, it doesn't have any power to the whole expression. And hence, this a can multiply through, and when it multiplies through, it can do away with one of the a at the denominator here. So that is why I cannot cancel the a and a down here.
Okay, thank you, sir.
You're welcome. So as I said, keep this thing in mind very carefully. This is how come we had the minus b over 2a coming on board for the line of symmetry. This is how it came about. This is another thing altogether. So remember our question that I gave you. I showed the question. I'll be writing it again. Our line of symmetry, I'm writing it again, so please take note. It's giving us x equal to minus b over 2a. We've seen it. And then if I want to get the corresponding value for y, the y value will be given as, watch. Remember, we learned that f of x is the same as y. So the y value will be given as 4ac minus b squared over 4a. 4ac minus b squared over 4a. That is how you can get the corresponding value for y when you know your line of symmetry. Because in some questions, they can even tell you just determine the y value. Just determine the y value in a given question without you going through the line of symmetry. So if you know these two relations here, please, you are good to go. Please, are we all clear?
Yes.
All right. So I'm going to put some questions down and we are going to apply these rules that we have here. I'm going to put some questions down, then we apply the rules that we've just learned. So you can take a screenshot to guide you, or you can also copy just these two of them, because the other ones later on you do it on your own and then you actually understand it better. So just copy the line of symmetry and then the y value down, and then let's box on to solve some questions. So moving forward to the next slide, let us consider the first question that we had. We were given y equal to x squared, the graph that we drew, plus 4x plus 2. This is what we had. That's the graph. Do you remember the vertices that we generated? Do you remember the vertices we generated when I drew the graph? Yes. What was the vertices?
-2 and -2.
All right. So we had -2 and -2. Now, graphically, this is the answer we had. But calculation wise, how do we get it? So knowing that our line of symmetry is given as x equal to minus b over 2a, then what it means is that from the quadratic function y equal to ax squared plus bx plus c, we must denote what our a value is. What is our a value from here? That's the coefficient of x squared. So what will be our a value from the function?
1.
1. Wonderful.
1.
Then we have b value as what number?
4.
That is 4. We don't need a c for now, so I don't have to call for the c. So having x equal to minus b, so minus b is minus 4. Sorry. So negative of 4 divided by 2 multiplying the a value, which is actually 1. So when we simplify this, we are going to get negative 4 on 2, which is the same as negative 2. My people, are you clear with that?
Yes, please. Yes, please.
All right. Then we are talking about the y value. How do we get the y value? We've learned that the y value is given as y equal to, do you remember the expression that I wrote? Yes, what was the formula?
Or AC minus
B squared all over 4a.
Thank you. So since we remember this, then it means we will need c in this sense. What will be c from the quadratic function that we had?
2.
That is 2. So let's substitute all these values into the relation here. That will be giving us y equal to 4 times a value, which is 1, times c value, which is 2. Then minus b value, which is the number 4, all divided by 4 times the a value, which is 1. So this is giving us 4 times 2, which is 8, minus 4, all divided by the number 4. This is what we are having. Is that it?
B squared.
Oh, sorry. It's so we have squared here. So that is giving us 16, right?
Yes.
Thank you. So we have 16 here. So that is giving us minus 8 on 4. And minus 8 on 4 gives us an answer of what? Negative 2. Please, are we all clear?
Yes, please.
So that gave us the answer we are seeing up here. So the line of symmetry and the corresponding y value gives you the vertices of a given quadratic function. The line of symmetry and the corresponding value for y together gives you the vertices of a quadratic function. Are we all clear?
yes, please.
It is not always that you are going to obtain the vertices as whole numbers or as integers. Sometimes you obtain the vertices as fraction. Yes, there was another question. I drew the graph which gave us some negative 0 point others and all those communities. Now I am not sure you remember those values very carefully, but let us work it out and then see the answers thereof. So let us consider that question. That question was I think minus 3x squared. So we had minus 3x squared. So y equal to minus 3x squared, and then minus x, and then plus 1. I hope you remember that was the question. Right. I hope you remember this was the question. And then we had the vertices. I have to go back before we can see it, but we don't have matter. I have a lot of things to bring on board. So let us move ahead. So from whatever we have here, we need to know our a value. What's the a value from the function? What is our a value?
Negative 3.
Negative 3. Wonderful. What is our B value?
-1.
Negative 1. And then our C value will be what? Since we need it for the Y value. So what's the C value? That is 1. So from whatever we have here, then our line of symmetry, x will be equal to minus b over 2a. I don't have a problem if you don't quote it, but for the beginning, you can quote it for it to remind you. So let's do our substitution. So we have minus of minus 1 divided by 2 times the a value, which is minus 3. Going further, this will give us positive 1 over negative 6. And that is our line of symmetry, which is the x value. And when you convert this to fractions, it's going to give you negative 0 points, some recurring values. You can check it from your calculator. Someone should do that for me and let me write it in decimals. Yes, when you convert it, what are you getting?
Negative 0.16667.
So negative 0.16666 all the way to infinity. Like there's a 7 at the end because of approximations. All right, that's, I believe you are clear. So that, and that was the answer we had when we actually graphed the whole thing. Let us go to the next. Finding the y value, we have 4ac minus b squared over 4a. So let's do our substitution. And that will be, y will be equal to 4 multiplying a value, negative 3, c value, which is 1, minus b value all squared, which is the number negative 1 all squared, all divided by 4 times a value, which is negative 3. Simplifying further, we are having negative 12 minus 1, all on negative 12. Going further, we'll have 11 on negative 12, which is the same as negative 11 on 12. Please, can you program this on your calculator to give me the values in decimals? What are you getting?
0.91666.
So negative 0. Go ahead. You left the negative. That's why I cut it short.
91.
Did you say
91.
91?
66.
All right. To infinity,
6.
right? All right. So this is what we are having. So these two values together, the vertices or the turning point for this function will be negative 1 on 6 and then negative 11 on 12. So this is the vertices. This is the vertices. My people, are you all clear? Clear.
Yes, please.
Okay. I want you to try one for me. Just try one for me. I just want you to try one for me. Are you ready for that? Just try one. Based on just the first method that we've learned. Try one for me. So I want you to determine the vertices for y equal to the function x squared minus 16x plus 10 plus 10. I want you to determine the vertices for this function. Within 1 minute, you should be able to finish it up. All right, so the time is up. Can you share your solution with me? Yes, what vertices did you obtain? What was the vertices, please? Please go ahead.
8, negative 54.
So 8, 54. 8,
Negative 54.
negative 54. Yes, any other answer apart from that?
So please, I got the same answer.
You also had the same answer. A third confirmation?
So I also had the same answer.
Perfect. 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 So using x equal to minus b over 2a. So we know our a value from here is 1. Our b value is negative 16. And then our c value is 10. We just substitute. So x is going to be minus times negative 16 all divided by 2 times 1. When you simplify everything, you end up getting positive 16 over 2, which is the same as 8. So your 8 is right. Then having y equal to 4ac minus b squared all over 4a. Substitution will tell us 4 times a value, which is 1. C value is 10 minus negative 16 all squared, all divided by 4 times a value, which is the number 1. Simplifying further, we end up getting 40 minus negative 16 all squared gives you an answer of what?
256.
So 256, right? 256 all on 4. So you have 40 out of 256. We are going to be left with what? Negative 216 all on 4. And negative 216 divided by 4 is an answer of negative 54. So my dear students, that is also perfectly right. I'm so happy you've been able to understand this concept within the shortest possible time. But this process that I went through with you, I mean this process here, please don't forget the process, because that's the genesis of how these two formulas were deduced. These two formulas were deduced. This process again is going to be used in our next lesson, whereby they will ask you to write the quadratic function in the vertex form. So the procedure here, you can't run away from it. Even though I've used variables over here, in my next presentation, it's going to be more of numbers as we have here. So that is the whole thing. Okay, so now that you've understood the first method, the second method is similar to the first method, just that you don't necessarily need to know this one, but after getting your s value, you substitute the s value into the original function to get the corresponding y value. That is the second method. So let us look at the second method, so that if you are okay with that also, then cool, you can go with it. So let me just pick this one. So the same question, I'm just copying this question to another screen, and then we do it together. I hope you are enjoying the lesson though. Okay, so this is what we have, and then we are asked to determine the vertices. We want the vertices. So determining the vertices, after we being able to generate the line of symmetry, which is minus b over 2a, and that will be giving us x equal to minus of minus 16 all on 2 times 1, and we end up getting the answer as 8. Now after getting our s value, you substitute the x into the function. So our value of x is 8. Let's substitute it into the original function. So y will be equal to 8 all squared minus 16 times 8, then plus 10. Please, does it make sense? Do you understand the substitution there?
Yes, please.
Yes,
Okay,
please.
so 8 squared is an answer of 64. And then 16 times 8 will give us an answer of 128. So then plus 10. So kindly simplify everything for me. Tell me the answer. 64 minus 128.
Negative 54.
All right, that is wonderful. That is wonderful. That is wonderful. So negative 54. My people, are you clear with what I'm doing right now?
Yes, sir.
Yes, please.
So I'm giving you different options as to how to get the same answer. Because I don't like students saying that elective math is difficult. You have options as to how to get the same solution. As I said, it is easy. It depends on how the lesson is presented to you and how you also react with it. It is very easy. So that is the second method you can actually apply in getting your vertices. First, determine your line of symmetry. Second, with the line of symmetry, substitute it into the original function, and then you get the corresponding value for y. You get the corresponding value for y. My people, are you clear with me?
Yes, sir.
All right.
Yes,
All right. All right. Very good. So take note of this also. I'm moving on to the next level. I have some few minutes for me to finish the lesson. So I'm moving on to the next level. The next level is they can ask you to determine the maximum value or the minimum value. So determine the maximum or the minimum value of a function, a quadratic function. Now, when a question of this kind is given to you, determine the maximum or minimum value of a quadratic function. Someone may be wondering, how do I do that? How do I do that? We've not learned anything today. It's only one thing that we've learned. We've learned that you can determine the line of symmetry given the expression x equal to minus b over 2a. This is the line of symmetry. And then the value they are talking about is either the maximum or the minimum value, and that is given as the y value, y equal to 4ac minus b squared over 4a. This is what we call the maximum or minimum value. This is how you determine the maximum or minimum value using this expression alone. Because when they ask of the maximum or minimum value, you don't need a line of symmetry. Straight ahead, you need this one, the y value. But you can go through a procedural manner to get the answer by first finding your line of symmetry, substitute the line of symmetry into the original function, then you get the maximum or minimum value. Remember, I told you early on that for every quadratic function, it is only one value you can obtain at a time. It is either a maximum value or a minimum value. You cannot obtain the two of them. And all depends on the coefficient of s squared. The coefficient of s squared will tell you that, okay, you are going to obtain a maximum or a minimum value. So please take note of all these things so that you don't get confused on the way. Therefore, per our question we had early on, whereby we had y equal to, let me write that same question again. We had y equal to x squared plus 4x plus 2. Even though the question says determine the maximum or minimum value of this quadratic function, which is this, you should know that per this question here, you are not going to obtain a maximum value, but rather you obtain what we call a minimum value. And remember, we said that this question is a minimum function for the fact that the coefficient of s squared is a positive number. Please, I hope you remember that.
Yes, please.
So in this case, when they ask you to determine the maximum or minimum value, you have to state your stand that this is a minimum value, and therefore the minimum value will be y equal to 4ac minus b squared over 4a. Then you substitute your corresponding values for a, b, and c into this expression, and that will be 4 multiplying 1 multiplying 2, then minus 4 all squared all over 4 times 1, whereby we've already solved this, so I don't have to stress myself. And the answer was what? Negative 2. Please, do you remember that?
Yes, please.
So our
Yes.
minimum value is negative 2. So this is where the importance of this expressions mostly comes into play. When you are limited as to find this exact thing for me, so that you don't beat about the bush, you just go straight to the point. My people, are you with me?
Yes, please.
All right. Please, any question?
Sir,
Yes, please, go ahead.
sir, please, will the answer for the minimum value always be negative?
That's an interesting question you've asked. It is not always that you are going to obtain a negative number for a minimum value. It is not always. It depends on the question. It is not always going to be negative. It depends on the question. I remember when I drew, please, can you all see my screen? Can you all see
Yes,
this?
please.
All right. When I drew the quadratic graph, now let me show you something here. Let me go to another screen and then show you something interesting. I wish I could have done it on the software for you to appreciate it. Now, you know, we have different quadrant system. So let's take it that I have the Cartesian plane here. There might be a scenario whereby the graph is minimum. So if the graph is minimum, you know, a minimum graph is holding water. So that graph will be here. When it happens that the graph is drawn and it's just hovering around this section, then it means the turning point over here, y value is going to be positive. So it doesn't mean that it's minimum for the fact that the y value is negative. No. Another graph that you can also obtain will be this way, whereby the turning point finds itself in a different quadrant, but it is pushed down into the negatives. So automatically per this graph, the y value will be a negative number. But per this graph, where the turning point is, the y value will be a positive number. So it doesn't mean that when they ask you to find a minimum value, the y value is going to be a negative number all the time. No. It can also be a positive number, but it depends on where the turning point is taking place within the quadrant system. Please, are you okay?
Yes, please. Thank
Oh,
you.
you're welcome. Okay, so let's take another example as to how to determine the maximum or minimum value of a quadratic function. So let's take it that we have this quadratic function as y equal to minus 2x squared minus 6x. We want to determine the max or the mean value. So my dear students, if I may ask, what type of value are we going to obtain per this function? What will you say? Pardon? Pardon?
Maximum value.
Maximum value. Very good. So we are obtaining a maximum value for the fact that the coefficient of s squared is a negative number. So we are obtaining a maximum value. Good. So obtaining a maximum value here, then getting the actual value, it is 4ac minus b squared all over 4a. So what is our a value here? Per this, what is our a value?
Negative 2.
Negative 2. B value?
Negative 6.
Negative 6. And c value? Yes, what do you think the c value is? 0. Wonderful. So let's substitute. So y will be equal to 4 times a negative 2 times c 0 minus -6 all squared, or divided by 4 times a value -2. Now the whole of the first term here is going to give us 0. This is -8 times 0, which is 0. So y will be equal to 0 minus 36, all on -8. So -36 on -8, y is what number? What's y?
4.5.
So we are getting
4.5.
4.5, or 4.5. So it means our y value is 4.5. Our y value is 4.5, and it's actually a maximum value. It's actually a maximum value. Please, are we all clear?
Yes.
All
Yes,
right.
please.
Try one for me. Just try one for me. Try one for me. So this time around, I have the function as, try this for me, determine the max or the mean value. Just one, because our time is almost up. We have y equal to 3 minus 6x plus 10x squared. Determine the maximum or minimum value of this function. So you tell me what value are we getting, and then you tell me what the value is. So I believe within 1 minute you can get it done. 1 minute is okay. All right, time is up. Can you share your answers with me? What value did you obtain? Yes, please go ahead.
Minimum.
So that is a
That
minimum
is a
value.
minimum value.
So minimum value. And what was the value, please? Y is equal to what answer?
2.1.
2.1. Is it exactly 2.1?
2.1. Yes.
Yes, please.
I'll be very
Yes,
glad that you
please.
leave the answers in fraction form. Or what's the fraction of it?
21
21
over
over
10.
21 on 10. So I'll always love you to leave the answer in the fraction form. I believe we are all clear about the lesson for today.
Yes, please.
Yes, please.
All
Yes,
right.
please.
All right. I'm so grateful you've gotten it. I'm so grateful you've gotten it. I'm so much grateful. Let me get you some questions so that I can try your hands on. In our first lesson, we said that quadratic functions can be written in different forms, for which it includes forms of quadratic functions. So we had what we call the standard form, for which the standard form is given as y equal to ax squared plus bx plus c. Then we had what we call the factor form, if you remember it very well. Yes, can you guess what the factor form is? Y equal to, yes, do you remember it? Either it is x plus a multiplying x plus b. This is the factor form. When you write it as two factors multiplying, that's a factor form. Then you have the vertex form. The vertex form. And the vertex form is given as y equal to what I just showed you. Either it is a into brackets x plus b all squared, then plus c. This is the vertex form. And this is the form I showed you the proof today. And from this form, you can generate the line of symmetry and then the corresponding y value. So you should be able to write quadratic functions from one form to the other. You should be able to change it from one form to the other. Each of them has advantages for knowing it. Each of them has advantages for knowing it. And when I mean advantages, when you write any quadratic function in the factor form, it helps you to know the intersection of the graph on the x-axis. When you are able to write the quadratic function from the standard form to the vertex form, it helps you to know the vertices of the quadratic function. And remember, the vertices of the quadratic function is what we call the turning point. And then the factor form tells you the point of intersection of the graph on the x-axis. The factor form tells you the intersection of the graph on the x-axis. So because I've done this one with you today, I'm going to change it from the standard form to the vertex form. The standard form to the vertex form. How to write a quadratic function from the standard form to the vertex form. So let us do one example. In our next lesson, I'll continue from there. In our next lesson, I'll continue from there. So let me just pick one question. Probably I can consider 3 minus 6x then plus 10x squared. So we have y equal to 3 minus 6x plus 10x squared. How to write or change to the vertex form. How to change the quadratic function from the standard form to the vertex form. So please, let's follow this carefully within the few minutes and I'll end my lesson over there. Now, before you can write any quadratic function into the vertex form, you have to use the process known as the completing of squares method. The process is completing of squares method. That's what you must actually use. And therefore, in order to use the completing of squares method, you must see to it that the coefficient of s squared is always 1. The coefficient of s squared is always 1. So this is what we are going to do. I'm just rearranging. I'll have 10x squared plus, 10s squared minus 6x plus 3. Now, the coefficient of s squared to be a positive 1 number, then I must factorize out the coefficient of s squared. So that will be giving me 10 out, open a bracket, s squared minus, yes, over here should be divided through by 10. So you have it as 6 on 10 x plus 3 on 10. My people, are you clear with what I've done here? Are you clear with the factorization that I've made? Good. So after working out this, watch carefully. This is where we are going to consider making the inner factor here a perfect square. The inner factor here is going to be a perfect square. And how do we make it a perfect square? You select the coefficient of x. The coefficient of x here is minus 6 over 10. Please don't waste your time to say that you are going to break down the negative 6 on 10, like to write it as 3 over 5. No, don't waste your time. Just leave it as it is. So we select the coefficient of x, which is negative 6 on 10. Then we halve it. That's the process. You divide it by 2. Now, when you divide this factor by 2, you are going to end up getting negative 6 on 20. Do you agree to this? Do you agree to that, please?
Yes, please.
Then
Yes, please.
you square the answer you've had. We are talking about complete. Okay, why are you lost? Why are you lost? So that I can help you, please. Why are you lost?
The negative 6 on 10
Okay.
divided by the 2.
Okay, so I said that the process by which you can actually make the inner bracket a perfect square. You want to make it a perfect square. A perfect square. So to make it a perfect square, select the coefficient of x. The coefficient of x is negative 6 on 10. Half it. So we divide that by 2. and dividing this by 2, you end up getting negative 6 on 20. If maybe you don't understand how we had the negative 6 on 20, this division sign will change into multiplication, and then we reciprocate the 2 and we'll get 1 over 2. So we'll have negative 6 on 10 multiplying half, and that is what is here. Please, have you understood that one?
Yes.
Okay. Then the answer you've obtained, you square it. You square it. At this point, you can reduce whatever value you have here. You can reduce it. When we reduce this, we are going to end up getting 2 will go here 3 times and 2 will go here 10 times. So you have negative 3 on 10 all squared. So negative 3 on 10 all squared is what we are obtaining here. Please, are we all clear with that?
Yes.
All
Yes,
right.
please.
So if that is clear, the negative 3 on 10 should be added to the first 2 terms of the function. So negative 3 on 10 all squared. Then that same number must be subtracted from the constant. So negative 3 on 10 all squared. So you add and subtract from the same function. But remember, the first 2 terms of the function you add. Then the last term of the function you subtract. Please, are you clear with me? Are you
Yes,
clear with
please.
me? Okay. So with the 60,
Go over again.
okay. As I said, in making the inner factor a perfect square, there are some processes you must go through. And what is the process? First, select the coefficient of x, half it, square it, add and subtract it to the equation or the function. And this is what we are going to obtain. Because we've gone through that process and this is what we had. Please, are you okay now?
Yes, please.
Okay. So upon
Yes.
doing that, the first 3 terms has become a perfect square. So you just pick one of the factors. So this is what you have. Pick one of the s squareds and pick one of the negative 3 on 10. So you have x minus 3 on 10 all squared. You put it in one bracket and square it. Then plus, then we simplify the 3 on 10 minus, here will give us positive 9 on 100. Then we simplify that. We are almost through. Please, we are almost through. So bear with me. Then we simplify this. So you have y equal to 10 into bracket x minus 3 on 10 all squared. Kindly use your, okay, fine. Let me work it out here. 3 on 10 minus 9 on 100. LCM is going to be 100. 10 will go into 100 10 times. Multiplying 3 will end up getting 30. Minus 100 will go into itself 1. Multiplying 9 will end up getting 9. So 30 minus 9 is actually 21 on 100. Please, are you clear with this?
Yes.
All right. So we have 21 on 100 here. Can I move on? We are almost through. Can I move on?
Yes.
So at this
Yes,
point,
please.
you can expand the 10 through. You can expand the 10 through. So expanding the 10 through, you end up getting 10 times x minus 3 on 10 all squared. And then when 10 multiplies 21 on 100, what are we getting? When 10 multiplies 21 on 100, what are we getting?
21 on 10.
21 on 10. And that is the answer for writing the y equal to 3 minus 6x plus 10 all squared in the vertex form. So this is the vertex form. This is the vertex form. And remember, this 21 on 10 was the minimum value you obtained. Do you remember that?
Yeah.
All right. So this is where I'm ending. In my next lesson coming, we are going to do more of how to change from the standard form to the vertex form. We'll be doing more work examples there. This one was just to keep us going, or to just keep the time running. So I'll be continuing from here in our next lesson. I'm so grateful you guys have actually been here, and I believe whatever I've taught today, you truly and deeply understand it. So this is what I want you to do for me. This is what I want you to do for me. There are some questions we've not answered on this sheet. I want you to actually find the vertices of the parabola form from this function. Yes, you are just finding the vertices. Find the vertices. Yes, I've shown you different methods of getting the vertices. We answered some of them. It's left with just a couple of them that we've not answered. So I want you to do all of them all together. Determine the vertices. And if you understood writing them in the vertex form too, you can try your hands on that one as well. I'm so grateful you have actually been with me. God richly bless you. And once again, I'll be very glad that you go to my YouTube channel, Math Made Easy with PDY. That's the name. Math Made Easy with PDY. That's a YouTube channel that I have. So go there. There are nice videos there for you. You can revise also over there. God bless you and have a nice day. Bye bye.
Bye.